Hello, welcome. Today let's try to solve another Leetcode problem, frog jump. Let me explain the problem a little bit, and after that I'll go to the whiteboard. And after my explanation of whiteboard, I will go to the code editor to finish the coding. So we are given an array of stools. So inside the numbers means the position of the stools. We just need to check if we can jump from the first stool to the last stool. So there are some conditions. For the first step, we are giving at position 0, and at this position we can only jump one step. Yeah, so this is given, and 0 and 1, so this is given. We can only jump one step. But after that, we can jump k minus 1, k and k plus 1 unit. So this means if we jump one step from 0 to 1, so for the next step, we can jump 0, 1, and 2 steps, because 1 minus 1 it is 0, and k also can equal to 1, and k plus 1 is 2. Yeah, if we jump 2 steps from 3, it means from 3 we can jump 1, 2, and 3 steps. Now let me go to the whiteboard to explain how can we solve it in DFS. After that, I'll go to the code editor to finish the coding. Yeah, let's just check the values of the stools. So the stools length is 2000. So this means if we use the DFS, normally we can solve the problem. But we also need some memorization. Yeah, let me explain the DFS first. So for the DFS, we're gonna design a DFS array. So for the DFS, yeah, so for the DFS, we're gonna prepare a position and jump. So the position is where we are starting from. Jump is how many jumps we can jump from this position. So for example, we're gonna start from 0 position because we are giving at 0 position, and from this position we can jump one step. Yeah, but here I will give a 0 because for this 0 I can use k minus 1, so it is minus 1, and k it is 0, and k plus 1 it is 1. So even I can use the jump from 0 as my initial jump, it still works because for my DFS there's always a k plus 1. If there's a k plus 1, it means I can jump one step. I can go out of this position to the next position if there is a 1. Yeah, and definitely there is a 1. So this is given yeah, by the question. So if there is no 1, it means we cannot jump. Yeah, we're gonna return false. So it is determined by the question. Yeah, normally we are giving at position 0. At this position, we can jump one step to 1. So this is why I'm gonna start from 0, 0, because I can always use k plus 1 to jump one step. So if I use k plus 1, it means for the position, it will be plus 1. I will go to 1, and my jump is 1. So this is my first jump. After that, I'm gonna decide if I can jump to this 3 or not. Yes, I can jump. If I jump 2 steps, so 2 is my jumps. Yeah, if I jump 2 steps, so the final value will be just 3, because 1 plus 2 is 3. Now we are at position 3 and jump 2 at this position. So we can choose 2 positions. We can jump 2 steps to position 5, or we can jump 3 steps to position 6. And at the same time, we would keep the jump value. It would be 2 and 3 here. So here would be 2 and here would be 3. Now we can go on. From here, we will jump one step. Let's check. Can we go back? Yes, we can. It doesn't mean we go back. I mean this value can be smaller, the jump, because this 2 can be 2 minus 1, k minus 1, it is 1. So the jump can become smaller. If we jump 1, it will be 6 and 1. If we jump 3, it will be 8 and 3. So for here, it's also the same. If we jump 2, it will be 6 plus 2, 8 and 2. It will be here. Now we can go on. So from here, 6 and 1, if we jump 2 steps, it will be 8 and 2. Now, what we can see is there are 8 and 2, and here is another 8 and 2. And this 8 and 2 cannot go forward because this 8 and 2 cannot jump to 12 because it needs at least 4 steps. But for this 2, it can only plus 1. It can jump 3 steps maximum. Yeah. So here will be false. I will give a F, and here will also be a false. Yeah. So this means for our DFS, we need some memory. Yeah. Just need to remember, if we jump from here 8 and 2 at this tuple, at this position and jump, we're gonna return false. So for the next step, if our DFS goes to here, if the first step our DFS goes to here, we're gonna return false. Now we will go backtracking until we go to here. Now what are we gonna do? We will do nothing. We just need to return false because this 8 and 2 and this 8 and 2 will be just return false. Yeah. So this is just an example to check the duplicate. So this means we're gonna also need to prepare a duplicate set. So I will give a set as, let's say I will give a set as visited. So the visited set inside will be the tuple of position and jump. It means if I jump to this position, I'm gonna return false. So for the next step, if I jump here, I'm gonna return false immediately. So for this example, we didn't get anything, but if this branch goes a lot of branches and finally it's gonna return false. So for example, this one, it will also go a lot. So for the next step, if I go from here, I will return false immediately. So this is the trick. Yeah, if we are lucky, we can jump from 5, 2 to 8 and 3. Now we can jump 4 steps, we're gonna go to 12 and 4. Now we can jump 5 steps, we're gonna go to 17 and 5. So 17 is our last position inside the stills array. So it means we find the result, we just need to return a true. Yeah, if we go to all the positions, we didn't find a result, we just need to return a false. Yeah. And for the time complexity, because we used the visited set, inside this set, we're gonna have a tuple of a position and jump. For the position, the length of the still is 2000, so we're gonna name it as n. And for the jump, it only has 3 positions. So basically, the time complexity is 2000 times 3, so it is still on. Yeah. Now let me go to the code editor to finish the coding. So we should also use another set. Maybe we can use the position set. So this position set is also another set. So this set is for all the stills. We're gonna store all the stills inside the set. Why? Because we're gonna check if some other positions, for example, if it is 2 or 4, so this position is water. It is not stills. So we're gonna return a false immediately. Yeah. Now let me go to the code editor to finish the coding. Actually, for the coding, it should be easier if we understand all the DFS. Basically, it's a template of DFS. So for our DFS, we need to prepare a visited set. So the visited set will be a tuple. Inside, it will be, as I explained, it will be position and jump. We should also prepare another set. I'm gonna define a position set. It means the stills. So it's gonna have a set and with the set stills. Yeah. So from the beginning, this visited set is empty because we didn't traverse the DFS, so it will be empty. But for the position, it will be a stills inside. Yeah, it means if some value is not inside the position, it means it is water. It is not still. Now I can use DFS. So for the DFS inside, there are 2 variables. So it is the position with jump. Yeah, so this means if I were to jump to the next step, I should know what is my previous jump. So this jump actually is the previous jump, and this person is my current person. Yeah. Now let's try to give a path first. And how should I call the DFS? So the DFS should start from 0. So this person is always 0. So this is given by the question. So initially the frog is on the first stone and assumes the first jump must be 1. So initially it is at 0 and it can only jump 1 to this person 1. So I will give a person as 0. Now let's write the DFS. Let's check some boundaries. If the position equals to the space minus 1, it means if we can go to the last stone, so we're gonna return true. So it means we can jump to the last stone, or we can check others. So if position not in position, yeah, if this position POS not inside the position, it means it is inside the water, we're gonna return false. Or for the tuple, for the position and jump, yeah, I will write this tuple first, and later on I will explain why I write it here. So for the position and jump inside the visited, it means we've already visited and it is a false, so we're gonna return a false. Yeah. Now we can go through our DFS. But before the DFS, we should store the positions inside the visited set. Yeah, if we didn't go from here, didn't return false, and now our visited set can add the tuple with position and jump. So we're gonna first of all, we're gonna add all those positions and jump inside the visited set. This means inside the set, these tuples should always be return a false. If it is return true, we're gonna return our final result. It means before we return the true or false, we need to put all those tuples, position and jump into the visited set. And now for the other branches of DFS, we're gonna return a false immediately. Yeah. Otherwise, yeah, so this is just for saving the time. Visited set should add this position. If we didn't do this, we're gonna have a time limit exceeded. Later on, I will try to test it. Yeah. Now I can return my final result. So the final result should be DFS with position plus jump minus 1. Let's try jump minus 1. It means k minus 1. Or let me write it here. I use a backslash for the Python. So this means I can write it on the second line for my function. So the position plus jump, or we just use this jump and our jump is still the jump. Or we can use the DFS with position plus jump. It's not dump, it's jump plus 1, and our jump will be jump plus 1. So this is just according to the question what we are giving. Yeah, if our current position is at this position and our previous jump is here, so for the next step we can go to position plus jump minus 1, and our jump should become jump minus 1. Here should be the same. Yeah. Now let me run it to check if it works. There's some syntax error. Let's just check. Invalid syntax. Now let me just make it one line first and check if it works. It's still the same. Let me check if there's some. Yeah. So here I forget or. I should use or. Now let me make it two line. I think it should work now. Now let me run it. Yeah, as you can see, it works. Now let me submit it to check if it can pass to all the testing cases. Yeah, as you can see, it passed for all the testing cases, and it's around 30% of all Python 3 submissions. Now let's do something else. If we didn't prepare this visited set, so what's gonna happen? So I just need to, comment this lines of code. So this means we didn't put the tuple inside the visited set. It means we're gonna just traverse the DFS. We would check all the positions of the DFS. So the time complexity should become, it should become 2 to the power of n, I think. So it's gonna have a time limit exceeded. Let's just check. Yeah, so uh, so first of all, the maximum recursion depth exceeded if we didn't use. Yeah, so it means for the DFS we cannot even use DFS because the depth for Python is 997 if I remember right. We cannot go to that deep. So this is why we have to use this visited set, put it inside, and we have to check it here. Yeah, so if it is inside the visited set, it means we've already visited this before, and it is a false, so we can return a false immediately. Or if this position is not inside our position, it is not still or inside the water, we're going to return false. Yeah, so that's all for it. Thank you for watching. If you think this is helpful, please like and subscribe. I will prepare more Leetcode problems like this. See you next time.